Hello, and welcome to Data Science 591 Group 7's pitch presentation for our Capstone project, the Fantasy Football Draft Assistant. Before we get into any advanced technical aspects of our Capstone project, it's important that we introduce the domain we'll be working in and why we want to make this project happen in the first place. So, fantasy football revolving around American NFL football has exploded in popularity in the United States over the last 25 years, with nearly 30 million people playing annually in the United States alone. This market consistently generates over $10 billion per NFL season annually. Now, really, fantasy football is just a small cog of a greater trend and growing machine of sports gambling in the United States as a whole, where sports gambling is already legal in 39 states, with more probably coming on the way in coming years. And proof of this is that Americans spent over $120 billion on sports gambling in just 2024. Now, the result of all these people, all this money and time and effort being put into these games and these leagues has created a community of fantasy football managers that are very intensely passionate about what they're doing, and they're always trying to find that new competitive edge, whether it be over their friends or their competitors. And this is where we come in. We will be building a fantasy football draft assistant recommender system with a customizable UI that managers can use to improve draft decision making in real time while they're drafting their teams. It will be built on multiple years of NFL and fantasy football data, and it will utilize advanced machine learning techniques to project fantasy point value and performance for these potential drafted players that managers can look at and use to build the best team possible while they're drafting, again, in real time. Now, as a high-level overview of the project as a whole, I would like to go over some highlighted features that we'll be incorporating into our recommendation system and our UI. So primarily, we want this user interface to be easy to use and customizable, and it will incorporate that advanced player recommendation system. This system will primarily utilize individual player and team stats from fantasy football, describing offensive, defensive, and special team performance, as well as the average draft placement or position of different players and different positions. With this recommendation system, we hope to create multiple machine learning models to predict the fantasy points scored and the just overall fantasy performance of these players. And we aim to do this through MLP regression or neural networks, XGBoost regression, and linear regression models. In addition, our recommendation system will incorporate rules-based player picking systems as well to ensure that the most relevant position suggestions are being made in real time. Again, that is very important to us that the managers can use this in real time and customize it for different position-based recommendations and sleeper picks, which may be players that you might regularly overlook, but we recommend you take in certain parts of the draft depending on who's available and who isn't and what other teams have been drafting. So this real-time player availability will be tracked and updated by the user, and this is all just with hopes of giving the manager the best possible recommendations in real time for them to use when drafting their teams. We also wanted to take a minute to note here the introductions for each of the group members in Group 7, or as we like to call ourselves, the general managers. So my name is Thomas Kiefer, and this is my second to last quarter as an MSDS student here at Drexel. And I'm mainly experienced in Python for data analysis, machine learning, and statistical modeling. But some of my teammates here are Caleb, who is in his final quarter and is working as a data engineer and is skilled in Python, SQL, web scraping, and machine learning. Hashim, who is an MSDS student with a background in biology, who is currently working on applying machine learning concepts to environmental management problems at his job. And lastly, but not least, David Blankenship, who is also in his second to last quarter here. He's a Navy veteran, has a bachelor's in astrophysics, and is skilled in Python for data science, machine learning techniques, and scientific writing. Lastly, before my team members get into the more technical aspects of what we've been doing and what we plan to do in the future for this project, I'd like to emphasize our user base and who we're really doing this for. And that's people just like us. We're all passionate football fans and fantasy football players, and we'd really like to help other fantasy football managers gain that competitive edge over their friends and competitors. So this system really is by the people, for the people, and we hope that people can use this to gain that competitive edge.
So now it's time to discuss the data sources. The data for this project was sourced from highly reputable sources to ensure consistency and accuracy. The data falls into two main categories: NFL player and team stats, and fantasy football draft rankings. The NFL player and team stats were pulled from 4 different sources: one main source, which was Pro Football Reference, and 3 supporting sources for statistics that were necessary for our fantasy points calculation, which we will address further down the line. The fantasy football draft rankings were pulled from Fantasy Pros, which contained average draft rankings from 4 massive fantasy football platforms. Here we have an overview of our data acquisition script. First, we run the main scraper, which collects and transforms data, merges offensive, defensive, special teams, and average draft position data, and performs minor feature engineering. Next, we run the fantasy points calculator. This script calculates each player's total fantasy points scored in a season. Then we merge the output from the main and fantasy points scripts for each year. Lastly, we combine each year's data into the final dataset in a wide format. An example to illustrate this is that we will have a column for each 2022, 2023, and 2024 passing yards, rather than a row for each. Our data was collected using a custom-coded web scraper, which we've referred to as our main script. One portion of this scraper collects offensive, defensive, special teams, and average draft position data using Beautiful Soup 4 and requests. Another area that we had to address was the need for points allowed to opponents for each individual week and each individual team. This functionality was added to the program using the historical score logs on Pro Football Reference. Custom logic was then incorporated to calculate the number of fantasy points earned each week. To merge the data from different sources together, we had to use several strategies to make the data fit. The first issue lied with our primary key, player names. This required significant cleaning to make sure that names matched and suffixes were handled. Name matching was fixed using custom callouts of known mismatches, like Gabe Davis versus Gabriel Davis. Suffixes were also removed using regex. Additionally, player initials were formatted to match, so an instance of this was J.K. Dobbins versus J.K. Dobbins. There was also an issue with data extrapolation for players that played for multiple teams. Since they played for multiple teams, their data represented multiple rows. Rows for each team they played for, and a row for total stats. Logic was implemented to select only the season totals for players which had this issue. Here we have a snippet of our function for cleaning player names. I want to call out the implementation of regex to remove suffixes and format initials. If you look towards the bottom, you will also see where we call out known mismatches. Here we review some minor feature engineering. We created a variable called average ADP, and this variable is the average of the 4 fantasy football platform rankings of players. This allows us to account for league-to-league variations. We also created a positional average draft position variable. This variable allows you to see a player's ranking among their position group and gives a more direct comparison between players in their respective roles. This is a screenshot of our function to add positional average draft position. Here you see we group by positions for ranking. We also coalesce in a value of 301 for all null values. This value will represent undrafted players.
So now I'm going to talk about some of the pre-processing steps that we did to finalize our data set. So the first one being is that we introduced a column name for year to explicitly include the season, and this preserves the seasonal context of each statistic and prevents potential confusion when working with multi-season data. We removed league-wide averages, for example, yards per game or completions per game, as they did not really contribute useful information for individual player recommendations and could introduce noise into our models. Some position labels required custom adjusting to align with standard fantasy football conventions. For example, fullbacks were converted to running backs and punters were converted to kickers, since they kind of function similarly when it comes to fantasy scoring and drafting. For kickers, field goals ranging from 0 to 39 yards were consolidated into one column because they share the same fantasy point value, and that in turn reduced our unnecessary dimensionality. Several position groups, such as offensive and defensive linemen, were removed because they are rarely drafted or used in fantasy scoring situations, which would likely improve the robustness of future player recommendations. And we actually did end up having one situation in which Taysom Hill of the New Orleans Saints was initially tagged as a unique hybrid tight end or quarterback, and we ended up reclassifying him as a tight end due to his recent primary usage in the position rather than at quarterback. And then when it came to missing data, we handled missing data in separate different ways to preserve the appropriate context. For example, blank average draft position values for players were filled with a 301 as a placeholder value, and we chose 301 because fantasy drafts typically consist of around 300 picks, and our original data source is capped at 300, so we chose 301 to be appropriate in that situation. And then other missing data values are currently being left unadjusted due to the way different models handle or prefer true nulls versus intentional zero values. And then in the future, we tend to treat this as a case-by-case basis depending on which specific machine learning model we're going to use. And then finally, we have a derived column in which we calculate the score of each player, and this is by applying a formula to their individual stats from that season. So we calculated PPR, or points per reception, and standard scoring values for each player per season based on widely accepted scoring rules. And so this ensures that the fantasy football draft assistant will be able to provide recommendations for drafters based on their individual league scoring settings. So players in PPR leagues would be able to select the PPR scoring model, and then players in standard leagues would be able to select the standard scoring model. And then when it comes to veracity, we have no significant concerns because our primary data sources, especially Pro Football Reference, which is considered as the gold standard for scoring and statistics, is a highly reputable source with easily verifiable statistics. And when it comes to ambiguity, fantasy football scoring is directly derived from well-defined and agreed-upon formulas, eliminating any ambiguity in our players' scoring values and eventual projections, because most fantasy football websites use very, very similar scoring systems. We are aware that there are custom scoring methods as well, however, those are a lot more uncommon. And then when it comes to interpretability or future pre-processing considerations, certain elements of the data set structure will be defined differently for separate machine learning models, so we intend to group some positions differently. For example, offensive players, since they're scored differently than kickers, and defensive players will have different models for different positions. And then some of these models may require and benefit from further pre-processing, such as feature selection and engineering and collinearity reduction, because if a quarterback throws more passes, then he will also throw for more yards. These kind of go hand in hand. And then we intend to explore multiple machine learning models, and we're currently planning to use XGBoost, a neural network, and linear-based regression models.
Now, I'd like to take some time to talk about some of the issues we ran into while putting together a data set. The first is the question of how many years of data to include. A larger data set with more years is going to provide a better statistical foundation for our machine learning model, leading to better performance. But it will introduce other issues that could decrease performance, such as shifting team dynamics, player turnover, and an evolving style of play. A smaller data set will ensure the relevance of the data, but will lack sample size for our training, which could lead to poorer performance. We also ran into the question of a tall versus wide format for our data. Wide meaning that each row represents a player and can include multiple years of data, whereas tall means that player performance for a given year is treated as a separate row. So in the wide-ish scenario, we simplify our feature engineering and modeling, but we're going to introduce issues of high dimensionality, which will make it harder to perform well. The tall format will provide more data points, but introduces complexity in recommender modeling and relevancy issues when we actually put together our model. So the current compromise we decided was to columnize 3 years of data in a wide-like format. This ensures relevancy, avoids dimensionality issues, and we're going to remain open to changing it as we go on, see our new model outcomes, and see if we need to course correct to a different style. We also ran into an issue of web scraping rate limiting. Some of the data sources we used actually have rate limits, and so we actually had to use sleep timers and in some cases even VPNs to ensure we could manage access. So we're fairly certain that if scraping at scale becomes necessary for our project, we're going to need to figure out and incorporate a scraping strategy. It's not currently necessary, but we do see it as a potentiality down the line. Another issue we have is the question of injuries or bye weeks. So if players are injured or if they're in their bye weeks, how is our system going to handle them? And it would add valuable context to our recommender to include this data. However, a lot of these would require automation of data collection or a live API, which is really just beyond the scope of this project. So we're not planning to do this at this current time. Here we show our weekly milestones for our project. And as we're entering week 7 now, we are currently on schedule for all deliverables and on target for all lines of effort at this time. We can break down now our future goals into 2 different categories, the ones remaining for this quarter and the ones that we're going to be looking into next quarter. For this quarter, we're going to continue our exploratory data analysis as well as begin our feature engineering and making sure we have all our deliverables complete. In the next quarter, we're going to be getting into the meat of our development with our model development and our dashboard development. Now, thank you very much for your time and listening to our pitch presentation. We do appreciate it. We hope that you continue to follow along as we continue to develop our fantasy football draft assistant throughout this quarter and the next quarter for our Capstone project. Thank you.